The Almighty God gave the tiger his prowess, the elephant his strength, the peacock his finesse, but to man he gave his brain. No wonder man has used his God-gifted brain to engineer technologies that has stunned the world from time to time. However, quite unusual by the standards set by man for himself, that he has been unable to use the ultimate source of energy, the sun. Yes, there are photovoltaic cells, yes, there are solar panels, but when it comes to industrial power generation, they're extremely cost inefficient. And hence our topic of discussion today, combining the mechanical efficiency of thermal power plant and the environmental friendliness of solar power plant, the solar thermal power plant, brought to you by myself, Alomoy Banerjee, second year mechanical engineering. Wishing a very good afternoon to all my dear guests out here. Let us begin this presentation. Now coming to a brief outline of the topics that will be covered in today's presentation. First, we will focus on the technological background of the project which we are concentrating on. Then, we will move on to the mechanical efficiency of the process, which will be followed by the economical feasibility or the market acceptability of the technology. And finally, we will conclude the presentation with the prospect of this technology standing on the Indian territory. Now coming to the first and the most important component of the solar thermal power plant, the heliostats. The heliostats are nothing but directional mirrors which orient themselves according to the direction of the sun in the sky. Each heliostat is accompanied by a control software which comprises of an optometer which senses the intensity of light and sends a command to the microprocessor. The microprocessor in turn operates the drive which consists of 3 motors for 3 specific axes of rotation, yaw, roll and pitch, and thus ensure that a definite amount of energy is concentrated at the top of the solar reflecting tower. And finally, we have a rigid sturdy anchor holding the heliostat sturdily to the ground in order to serve as a specific axis of rotation for perfect rotation of the heliostat. Now these heliostats ensure, as I said, that a definite amount of energy is concentrated at the top of the solar reflecting tower. Now the energy is concentrated at the top of the solar reflecting tower. It needs to be transferred to the place where steam is generated, as in case of any power plant. Now this transfer medium acts as the HTF or the heat transfer fluid. The criteria for HTF are all mentioned here. However, the first 2 criteria ensure that minimum amount of pumping energy is required to pump that heat transfer fluid. Now, as we all know, for any mechanical system, minimum power consumption ultimately contributes to the higher efficiency of the system. And that is exactly why these criteria are so significant. Now, considering all the criteria, we use synthetic aromatic hydrocarbon oil as the effective medium of heat transfer, which transfers 85% of the source heat from the source to the destination point. And since in this case we are dealing with extremely high temperature out here of over 600 degrees Celsius, what we use as a material of construction is haste alloy. Haste alloy is basically an alloy of nickel along with various other materials like iron, carbon, vanadium, manganese, magnesium in various proportions which can bear extremely high heat. By extremely high heat, I mean haste alloy is basically used for material handling in molten aluminium plants which deal with temperature of over 2000 degrees Celsius and which satisfies the condition right here. Now the heat is transferred via the heat transfer fluid to the heat exchanger supercritical fire tube, or we may use water tube steam generator. There water is converted to supercritical steam at a pressure of 22.1 megapascal and 550 degrees Celsius. Now, as we know, in case of mass generation, water tube boilers are always more preferable and that is exactly why we can use water tube boiler here in case of a solar thermal power plant for mass generation. In case of a water tube boiler, the heat transfer fluid, instead of remaining in closed tubes, it will be concentrated into an open chamber inside the boiler through which heat will be diffused out. Now the steam containing huge amount of thermal energy is led into a reaction axial flow supercritical steam turbine. The tapering structure of the turbine ensures that there is a pressure drop at the exit rather than the entry. Now, as we all know from the steady flow energy equation, the sum of net energy heads are constant. Now the tapering structure of the turbine ensures that there is a pressure drop at the exit rather than the entry. The pressure drop ensures that there is a drop in enthalpy. And as we can see, a drop in enthalpy ensures that an increase in velocity must take place to take the sum of the net energy heads constant. Thus, the thermal energy which is entering the turbine is ultimately converted to kinetic energy at its exit. This kinetic energy generates huge amounts of torque to rotate the circumferential blades of the turbine, which generates high amounts of mechanical energy to be ultimately converted to electrical energy, which is the ultimate output of any power plant. Now the technology demonstrated by me till now is dependent on the presence of the sun in the sky. Now, we cannot commercially actually go on and say that we will create a power plant which will generate only during the day. And that is exactly where the contribution of molten salt technology comes in. The molten salt technology basically consists of a mixture of sodium nitrate and potassium nitrate in the ratio 3:2, which is more efficiently known as saltpeter. Experimentally, it has been found that it holds on to maximum amount of heat for a huge amount of time. Statistically speaking, an 80 feet tall reservoir and a 30 feet in diameter can store enough solar thermal energy to actually fuel a 100 megawatt solar thermal power plant for 7 to 8 hours after sunset. Now, recent research results show that we can use aluminium dross and steel slag as an efficient solar thermal storage device. In fact, experiments show that this aluminium dross and steel slag I am talking about right now can rise to a temperature about 1000 degrees Celsius, which is much higher than the molten salt, which rises to a meager 600 degrees Celsius. This, as you can see, is in perfect complement with the rising steel production throughout the country in India. Now, if this result is actually being applied to a project, we can imagine how further economization of the solar thermal power plant is possible, because we are needing no investment absolutely for storing the solar thermal energy. As the industrial waste we are generating, the tons of industrial waste we are generating per year is actually contributing to the ultimate solar thermal storage device in our country. Now this is the basic power plant design I have been talking about for so long. With this slide I come to the end of my first subtopic, that is the technological background of the entire project. Before I move on to my next subtopic, that is generation efficiency of the project, let me summarize the entire discussion in brief terms for you. Here we have the heliostats concentrating the solar energy to the top of the solar reflecting tower, where solar energy is actually concentrated and transferred via the heat transfer fluid to the reheater and the superheater zones of the boiler. And then we have the steam containing high amount of thermal energy being transferred to the turbine for rotation, and it generates huge amount of mechanical energy to be transferred to the electrical grid for transmission. And then we have the cooling tower, as for any power plant, for condensing the rest of the steam, and the feed pump completes the cycle. Now here you can see a hot molten salt and a cold molten salt reservoir, which actually accounts for the maintenance of consistency of power generation even at night time. Now no technological analysis is complete until and unless we bring some numerical data into it. Here what I have try to do is avoid the tedious technological calculations involved to avoid the boredom of the presentation. Instead, what I have done is tabulated the results from those calculations in form of a chart such that it is easy for the audience to understand. Here, as you can see, we are using H1 heliostats of 95% reflection efficiency and each of an area of 3 square meters. These H1 heliostats have a reflective capacity of 2050 watt per square meter. Thus, if we are installing 40,000 heliostats, we are getting the net thermal energy concentrated by them as 265 megawatts. Now, as I said, the heliostats are 95% efficient. The net output power concentrated at the top of the solar reflecting tower is 250 megawatts. From there, the HTF or the heat transfer fluid which we are using, synthetic aromatic hydrocarbon oil, as I said, is transferring 85% of the source heat to their destination point. That is the steam generator. Thus, we can say that the net heat which is concentrated in the steam generator is 215 megawatts. Now, in the steam generator, which is a water tube boiler for mass generation, I am considering it is 89% efficient, which makes the energy drop to 193 megawatts. However, this is followed by the least efficient cycle of the entire solar thermal power plant, that is the thermal to kinetic energy conversion in the reactor axial flow supercritical steam turbine, which makes the energy a huge drop to 88 megawatt at a meager efficiency of 45%. And finally, we have the highest efficient cycle to conclude the solar thermal power plant, which makes the net output come to 85 megawatt. The objective of this slide is to show my audience that if we are going for mass scale generation at par with the thermal power plant, which is in accordance in our country right now, that is 85 megawatt, we need an H1 heliostat of 40,000 in number and a reflection efficiency of 90%. Now, this is the cost analysis of a solar thermal power plant that I have actually tried to put up right here. This is based on the data which is established on a solar thermal power plant in Gujarat in recent years. The megawatt per square meter is actually concerned for calculation, and this is exactly why we have put up a 100 megawatt solar thermal power plant investment. Since this is based on the recent establishment of the power plant in Gujarat, the pricing you can assume is in tandem with the recent market prices generally available right now. Now, we have divided the cost into a number of broad sectors here. Here we have assumed the power block, which is accounting for at the turbine, the cooling tower and the feed pump, is accounting for 19% of the entire cost. Next, we are moving on to the HTF system, that is the heat transfer fluid, as I said, and the pumping of the fluid, which accounts for 11% of the entire cost of the generation of the solar thermal power plant. Next, we have the part which is incurring the highest investment, and as expected, the solar field collectors are incurring the highest investment. 44% of the entire installation cost is being incurred by the solar field collectors. And then we have the site work and the services accounting for 10%, and the balance of the power plant, that is the molten salt technology or the solar thermal storage devices, we are accounting for right now, it accounts for 16%. Now the point is, this entire thing sums up to rupees 300 crores. Now, if we are imagining that we are using aluminium dross and steel slag, which is unfortunately still in research stage and is yet to be applied to a project, 16% of the installation cost is actually eliminated. Now, just imagine if we are considering a rupees 300 crore investment, 16% elimination means we are going for a reduction in installation cost by rupees 48 crores. Which is making the offer even more lurable, even more attractive to the investors out here. Now, this is analyzing the entire solar thermal power plant in terms of the market parameters. The market parameters which analyze the efficiency which is being brought about by the solar thermal power plant. as I said, an installation cost of rupees 300 crores for a capacity of 100 megawatts. Now the crunch point is, if we are selling the power at rupees 4 per unit, ladies and gentlemen, mark my words, rupees 4 per unit, which is much lower than the power tariff we are experiencing for the thermal power plant right now. We will recover the entire cost of the power generation within 313 days, that is within a year. However, this calculation is done considering zero maintenance charges. So even if we are considering maintenance charges out here, it will hardly account to 1.5 years, within which the entire cost of installation will be reimbursed back to the investor. Now here we have got three terms out here: the megawatt per square meter, the cost per square meter, and the cost per megawatt. Now if we are talking about a major drawback this technology provides, is this extremely low megawatt per square meter. Research has been again going on in our neighboring country China, which shows that they can install solar space stations in the space as solar concentrators, which will be converting the concentrated solar energy to laser beams, which will power an entire thermal power plant setup. Just imagine the entire terrestrial area for a solar device, solar collector is actually gone, and we can have the efficiency as high as a thermal power plant in terms of megawatt per square meter. Now it's futile to explain a technology until and unless we are talking about the prospect of this technology standing on the Indian territory. As you can see, here we have most of the zones in the Indian territory actually accounting over 6 kilowatts hour per square meter. You can have very high solar irradiance zones in Rajasthan or in cases of Ladakh, where you can have very high prospect of a solar thermal power plant, and this is as expected because the Tropic of Cancer is ripping the country to the center of the country with the tropical and the equatorial zones existing in perfect harmony, and hence exhibiting very high prospect for a solar thermal power plant. Now these are the reference articles I actually referred to in order to prepare this paper. My dear audience, we all talk about a green world. We all talk about a world where green technology will reign supreme. We all talk about green revolution, but we all go back to our home and use thermal electricity. Until and unless we are going to change, this world is not going to save itself from the perils of global warming. Until and unless we are going to lead this green revolution, this world will never start its green revolution on its own. We are the most intelligent people on the earth, as I said to begin the presentation, and it's our responsibility that we have ignored for so long that we haven't taken care of the green technology and allowed the world to swamp into the grips of global warming. My dear audience, since we are the most intelligent animals on earth, if we have the willpower, we can establish a green world. If we have the willpower, we can lead the green revolution. If we have the willpower, we can achieve the impossible. आसमां सिमट जाएंगे तेरे बाहों में, जरा चाहत के बाहें फैला कर तो देखो. Thank you.